So the next thing that I suggest people look at pressure considerations. We, as chromatographers, we're doing many different types of chromatography in open top containers with gravity flow, in sealed containers with resins of large diameter pore size, particle size, small diameter particle size, and the particle size, in most cases, is driving the back pressure through the column, and we want to understand, for the resin that we have decided on, is it very large particles of resin that provide minimal back pressure, in which case our column maximum operating pressure is not as big a consideration. If we're looking at resin which has much smaller particle sizes, it's going to drive the pressure, the back pressure for flow up dramatically. And we can't arbitrarily take a column and just unpack it because it had some 90 micron resin in it and decide we want to put 10 micron resin in it and run it. We're clearly going to have some flow and back pressure issues. So again, we should be very cognizant of the fact as we go through the selection of our column, what is the back pressure? And back pressure, as it's coming up, is going to create a potential safety issue. If we are setting our pressure limits on our system, we clearly need to understand what the pressure limit of the column is. Now, I know some column manufacturers post a maximum allowable pressure of their column. That is the pressure that is close to the fracture point of the column. And if we're running our process or our purification and we have a pressure spike, even if it's a minimal pressure spike, it can exceed the pressure cutoff quickly of where we set the system pressure. I've seen many cases where we have set the maximum pressure for our system very, very close to the operating. We get a pressure spike, the column fractures, and we have a catastrophic failure of the column. Now, because of the fact that columns are flooded with liquid, as we know, is incompressible. We don't build up a lot of dynamic pressure. There generally is not as much of a safety issue for a dynamic explosion of a column, although in our opinion, not only all columns should be protected in some way from the operator, but also we should understand, what is the failure point of that column? Is it 5% over the stated pressure by the manufacturer? In the case of our own products, we test the products all at 1.75 times as a non-destructive test, all columns that ship out the door. Columns that are made from glass, even though they can be appearing to be without any kind of impurities, dents, dings, cracks, there is inherent stress that is residual from the manufacturer when the glass is made. The glass is normally annealed, and you cannot see the residual stress inside of a column. Here in our own lab, we have special tools where we can create visibility of that internal stress. But oftentimes, even though we can take a column and test it, it appears to be fine. It can fracture unexpectedly, and when operating columns for safety measures, we should always be cognizant of the fact that safety is number one. Also, as I had mentioned at the beginning of this presentation, columns for purposes of this discussion can be either glass or plastic. Glass obviously is much more fragile and brittle, and when there's a failure, it tends to be more of a dynamic failure. Plastic will tend to crack and relieve its pressure. But in any case, we want to understand when we're selecting a column, are our buffers, both our packing buffers, storage buffers, cleaning buffers, are they all compatible with the materials that we have in our column? So we want to take a look at that and talk to the manufacturer. We want to look at solvent compatibilities. And even at some times we want to consider temperature in the selection of our column, whether the temperature range that we anticipate will be okay for the application that we've selected.